Hi, in this video, I'm going to lecture on Mapreduce and Hadoop. Okay, what is Hadoop? Hadoop basically is an ecosystem. When we talk about ecosystem, it is not just a single system, but it is a group of systems within a system. Okay, so Hadoop can be defined or can be described as a framework which deals with big data, but it is not like other frameworks, okay, because it's not a simple framework, but it is actually a family of systems, okay, which is tied up under one umbrella called Hadoop ecosystem. Okay. So this is pretty much, in general, how it looks like. These are its components. Let's go through each and one of it. Okay, the first one, okay, we start off at the very bottom of this framework where the data sources are. So you can see here, you have two sorts of data sets, the data sources. One is the structured type as well as the unstructured or semi-structured type. Okay, so in order for you to extract data from a structured database, you need to use scoop, which is, okay, a SQL plus Hadoop, so it becomes a scoop. So you can just remember as kind of like an ice cream scoop, okay, where you extract, kind of like extract ice cream from the ice cream tub, So the next one is called Flume. Okay, so Flume is the one that is responsible for extracting unstructured and structured and semi-structured data. So both Scoop and Flume are capable of importing as well as exporting data to and from the data sources. Okay, so once these data are extracted, it will go or it will be placed in a Hadoop distributed file system, or better known as HDFS. Okay, so a HDFS is actually a collection, okay, a collection of small sized blocks of data placeholders. Okay, so I'd like to imagine it as kind of like a group of computers, okay, within a lab. So you can have small, each and one of those computers stores data. So HDFS is a distributed file system whereby each and one of those files are small, but they are many. Okay, once we have the HDFS data in the HDFS, the next thing that Hadoop will do is to take it, okay, to get this data, and then will be placed into the Mapreduce framework. Okay, you may have heard, quite a lot about this Mapreduce, okay, especially when it's relating to big data. So what Mapreduce is basically, it is a programming method. Okay, it's a programming method. Therefore, you can actually apply Mapreduce, okay, this method, on any kind of language, okay, that you are familiar with. So it can be written, by using languages like Java, C++, Python, Ruby, etc. Right? So what's important that here is your understanding on how this method works. Okay? So Mapreduce framework is specific to solving a certain kind of problem which is described as embarrassingly parallel. Okay, so what is this embarrassingly parallel problem? It is a problem where a single task can be divided into smaller tasks and later recombined into a single output. Okay, so you have this big problem, for example, you chunk it up into smaller sub-problems, get it solved, and then you recombine this whole problem again. okay, into one big solution. Okay, so if in the case that you have a problem, but it is not possible to chunk it, okay, to divide it or to partition it uniformly across into different subproblems, okay, and then recombining it into a solution, therefore you should not use Mapreduce. Okay, so Mapreduce is a specialized kind of programming method whereby you can only or should only use it for this specific kind of problem, which is the embarrassingly parallel problem. Alright, so in Mapreduce there are two phases or two functions. The first one is map and the second one is reduce. So what does the map function do? Okay, the map function divides a big task into smaller tasks to be processed on different units of machines. These should be in the form of key value pairs. Okay, so you're still not running away from key value pairs because we are talking about big data, and as you know, lots of big data are in the form of unstructured data. Okay, so that's why Hadoop is famous for big data, especially for unstructured data. So there's an example here, which is a word count, okay, which means that you have a corpus, okay, you have a document, let's say, okay, a document, and then you want to count the number of the unique number of words, okay, the unique number of words. So sorry, you're not trying to count the unique number of words. You're trying to count the frequency of unique words. Okay, so kind of like a bag of words. Okay, so what you can possibly do is that you can divide the document into different parts. Okay, into different partitions. So these different partitions will then be run on different machines. Okay, on different machines, and for that small chunk or portion or partition of document, that tiny unit of compute will count the frequency, yeah, the frequency of each unique word. So let's say within the first partition you have the word saya suka susu. Saya, contoh. So it means that saya will have a frequency of 2, suka will have a frequency of 1, okay, susu will have a frequency of 1. And then the next partition, maybe say Ahmad suka berjalan kaki suka-suka. Okay, so for the word suka, okay, the next partition of document on a different machine, computing machine, that computing machine will only calculate that second partition, and it will be able to calculate the frequency of suka 3 times, okay, frequency 3 times, Ahmad 1, berjalan 1, you know. So that's how it's done. So once that is completed for each and one of those partition, okay, then you go to the reduce phase or the reduce function. What reduce does is basically to recombine all these small tasks, okay, all these small processes that you have done for each and one of those partition of documents, and then recombine it again. So if let's say in partition 1 has saya, okay, and then in partition 5 has another saya. So in partition 1 you have 2 saya, and in partition 5 you have 3 saya. So within the reduce phase or the reduce function, it will actually combine this saya word, okay, and put the frequency as 2 plus 3, which is 5. Okay, so you get the entire number of saya word occurrences. Okay, so it occurred within your document 5 times, only it was actually being calculated in different compute machine. Okay, So Hbase, okay. All right, before that, I'd like to give another example. So you can actually put an example, okay, an example of, let's say you are Food Panda and you're given ₦1,000,000, okay, to purchase for your business. So maybe you say, okay, I'm going to decide to purchase, you know, either 10 Viva cars or Axia cars, small cars, or or alternatively, you use that 1,000,000 to buy one Lamborghini. Okay, so if let's say you decided to buy one Lamborghini because it's fast, it's you know, it should be able to go and deliver food quickly to all your customers. The thing is that this is still just one big Lamborghini, and it still has to go from one location to another location sequentially. So if let's say you at the same time, for that very day, you have 10 people ordering from your company, okay, your Food Panda. So there are 10 people requesting for delivery. So if you have a large, you know, fast Lamborghini, you still have to go one by one to each and one of these 10 requesters. Yeah, okay, and you have to understand there will be traffic jams, okay. So the total time that this one Lamborghini can actually finish executing, you know, delivering to all these 10 people, you know, could be very, very long, as compared to if you have 10 Axias not Axiata, no, Axia, Viva, Kancil, okay, that's those small cars, okay. So even though they are small, but all 10 go off and deliver to all these, to the 10 requesters, okay, then the time, we can say that the end time or the completion time will be the same for each 10 of this in average, and it will be just a fraction of what the Lamborghini can do, even, you know, considering with traffic jam and everything. Okay, so this is what Hadoop is doing. This is the strategy of Hadoop. Many small compute machines, okay, as compared to one large one. Alright, and where kalau misal Lamborghini tu dia rosak or something, it got broken, tire problem, engine problem, it's more expensive, isn't it, to actually do some maintenance on it. Okay, as compared to, for example, one Kancil, okay, one tiny car, one Viva, for example. And then if let's say more and more people, you know, you get more and more requests for food delivery, all you have to do is just to add more Vivas. Okay, just more Vivas. You don't have to do anything with the current Viva. But with Lamborghini, you have to what? Put in macam turbo or something, maybe, you know, to look like a Batman's car. The Batmobile, you know. So it is more expensive. But you can only do sequentially one at a time. Okay, one at a time. So that is sequentially. Okay, I hope you understand the example, okay, to reflect what Mapreduce framework does. Okay, moving on to the next one is Hbase. Okay, what is Hbase? Hbase is actually a NoSQL database that runs on top of HDFS. Okay, it was created for large table which have billions, okay, of rows and millions of columns with fault tolerant capability and horizontal scalability based on Google Big Table. Okay, what does it mean by this horizontal scalability? This is referring to the Viva tadi tu, okay, just now. It means that if you need more power, all you have to do is to add tiny ones, okay, to cater for it. Because remember, in this for Hadoop, okay, you are solving an embarrassingly parallel problem where you can actually chunk things up, okay, chunk the problem up, and then, okay, combine it again after you have processed each and one of those sub-problems. So Hadoop can perform only batch processing, and data will be accessed only in a sequential manner for random access. Okay, so that is its characteristic.